Here we're gonna, in this lesson, we'll provide an overview of smart contracts and their importance in decentralized applications. We will cover the basics of Solidity, the most widely used programming language for smart contracts, and join participants to helpful resources such as documentation, examples, and tutorials. Let's first start with Ethereum's smart contracts. Ethereum smart contracts offer a secure, irreversible transactions without intermediaries using program languages like Solidity, Viper, Serpent, etc. So, smart contracts are an essential aspect of the Ethereum blockchain, providing credible and tamper-proof transactions that are trackable and irreversible. These self-executing contracts are high-level program codes compiled to EVM bytecode and then deployed to the blockchain, enabling transactions without intermediaries. Okay, now let's talk about Solidity. Solidity is a programming language specifically designed for creating smart contracts on blockchain platforms with a syntax similar to C++ and JavaScript. Solidity's advanced features, open source nature, and easy-to-learn syntax make it a popular choice for blockchain development. It enables developers to write code that executes automatically, making it ideal for creating decentralized apps that operate without human intervention. Solidity includes variables, functions, classes, arithmetic operations, and string manipulation, and so many other features that make it a powerful tool for creating a secure and reliable apps. Ethereum Virtual Machine, or EVM, is a runtime algorithm that executes smart contracts on the Ethereum blockchain platform. It provides a secure and trusted execution environment for untrusted code by running a global network of public nodes. The EVM operates on a consensus algorithm known as proof of work, or now recently page, and it's highly specialized chain. Additionally, EVM ensures that communication is established without interference, which is critical for creating a reliable and secure platform for executing a smart contract. The EVM's gas mechanism controls the amount of computational resources used by each smart contract, which helps prevent spam attacks and optimizes the code for improved efficiency and performance. These features have enabled a development of dApps, bringing greater transparency and efficiency to various industries. But now let's kickstart the job with the first smart contract. Let's go actually to each single line and explain it. So the first line here, my pragma Solidity, actually function as guidance for the compiler on how to handle the code. For Solidity code, a version of pragma must be placed at the beginning of the code to indicate the version of the Solidity compiler that should be used. This is important to ensure that the code is not incompatible with future compiler versions, which may bring about changes. According to the code mentioned, it can be used with compilers of version 8 or higher, but not with version 1. So the next line, contract subtraction, begins the definition of the contract. The next 3 lines are actually the state variables I am working with Ethereum blockchain. State variables are utilized to store information in the contract storage permanently. By defining these 3 lines, we are defining 3 state variables that are going to be explained in more details in the next slides. And these 2 lines, the one here and the one here, actually declare functions. The first one has a public access modifier and accepts two Boolean 256 type parameters. It's actually an illustration of a basic smart contract that modifies the value of state variables. Actually, both functions is open for everyone to execute, and it permits them to override the values of state variables that are recorded in the global state. And thus, the smart contract can be accessed as long as someone operates at least one node of the Ethereum blockchain. Let's talk about some smart contract execution tools and environments. So there are many ways to execute a Solidity smart contract. Here, we're going to mention some. One way to do so is to firstly download and install Node.js, followed by the installation of Truffle and Ganache. Next would be a Truffle project, which should be created, and a development network must be set up. And the smart contracts can then be created and deployed. And the last one could be to interact with the smart contract in the Truffle console and write tests to verify the main features of your Solidity. On the other hand, there is another option which is probably employed using the Remix IDE for compiling and running Solidity smart contract, which I'm sure you are familiar with this system.